So we're going to go more in depth with the use of nmap for discovery at layer 3 and layer 4. First, we are going to filter ICMP traffic on Wireshark to see what is being sent. So we'll enter the filter ICMP and then select our interface and start sniffing. And then we're going to run an ICMP ping request with nmap on a range of remote IP addresses on the web. So we'll use nmap, then -sn to suppress the port scan, then -pe to specify the ping scan, and then enter the range of IP addresses. In Wireshark, we see a complete series of ICMP ping requests and replies from live hosts. Now we'll stop that session in Wireshark and create a new session. And then we'll use the exact same command, but this time with a private range of IP addresses on our local area network. So we'll run that command and then change the range of IP addresses. And as you can see, we almost immediately get results of 9 hosts that are up. However, Wireshark indicates that absolutely no ICMP traffic was passed. So why is this? Well, let's change our ICMP filter in Wireshark to a filter that only allows us to display ARP packets. So we'll use eth.type == then 0x0806. You'll notice that even though we specified an ICMP ping scan in nmap, it will first attempt to locate them using layer 2 because that's a quicker response. So when using a ping scan in nmap, the scan is actually adaptive and will use the type of scan that provides the quickest results. Layer 4 discovery can be useful if systems cannot be discovered at layer 2 because they aren't on your local area network, or can't be discovered at layer 3 because they are configured to not reply to ICMP traffic. A scan that we can perform to discover systems at layer 4 is a UDP scan. So let us adjust our Wireshark filter accordingly. Change the filter to UDP, &&, then IP.src for IP source address, and then ==, and then specify the IP address of our Kali system. And then we already have data there, so we'll go ahead and start a new session. And then to perform our UDP discovery scan, we'll use nmap-sn to disable the port scan, and then -pu and specify the UDP port that we want to scan, so port 53, and then the IP address range that we want to perform that scan on. The result is a list of DNS server status requests. Now if we change that filter to only show traffic that's being sent to our system with IP destination address and our home address, then you'll see a series of both automated host unreachable responses, or in the case of live hosts, a standard DNS query response. DNS is a good option for a UDP discovery scan because it's a commonly used UDP port. Another option for layer 4 discovery is a TCP ACK ping. To do this, we'll change our filter in Wireshark to TCP, then &&, then IP source address is equal to our Kali IP address. And then to perform the ACK ping discovery, use nmap, then -sn, and then the IP range that we want to perform the discovery on, and then -PA, and then the TCP port that we want to perform the ping on, the ACK ping on, and we'll use port 80, since it is also a commonly used TCP port. By reviewing the Wireshark data, you'll see that a series of unsolicited ACK replies were sent to each of the hosts in the range. If you look at the replies then sent to our system by changing it to the IP destination address, you'll see that all the live hosts that have services running on port 80 will return an RST packet to reset the connection because the ACK packet sent to them was sent out of context. This is an effective way to trick a machine into indicating that it is alive at the target IP address. So those are some various ways that you can use nmap to perform discovery at both layer 3 and layer 4.